Here, this circuit shows the fixed bias circuit. In the case of fixed bias circuit, this is the input resistor, output resistor. That is these are nothing but current limiting resistors. These are nothing but your current limiting resistors at the input side as well as output side. Okay. Now here, for this fixed bias circuit, I am going to write the input equation as well as output equation. Nothing but I am going to apply the KVL to the input side as well as KVL to the output side. Now, what are the elements connected to input side? That is VCC, resistor RB, and voltage across this transistor VBE. Okay. Now, VCC is your voltage, right? Whereas here this is voltage drop. Across resistor voltage drop. Across transistor also voltage drop. That means VCC minus IBRB minus VBE is equal to 0. Algebraic sum of the total voltage around your closed path is equal to 0. So that's why it is VCC minus IBRB minus VBE is equal to 0. From this, I am writing the equation for base current IB. Now IB is given by VCC minus VBE by RB. Now this is your base current equation in the case of fixed bias circuit. Okay. Now after that, I am going to apply the KVL to the output circuit, nothing but collector circuit, this side. Okay. Now VCC voltage rise, whereas across this resistor voltage drop, across this transistor voltage drop. Now it will become VCC minus ICRC minus VCE is equal to 0. From this equation, I can write the output voltage equation VCE as VCC minus IC into RC only. Okay. Now, from this equation, I am writing the equation for collector current only. IC is given by VCC minus VCE by RC. Now, here in this case, the supply voltage is constant and the output voltage is constant for short duration and RC also constant. If all these are constant, then what will happen to the collector current? IC is going to constant. This is for short duration. That means for short duration, the collector current is constant. That means quiescent point is stable. That's for short duration. Okay. Now for long duration, what will happen? For long duration, that means after connecting this circuit like this, there is a increase of, that means if the for long time, after connecting the circuit for long time, that means 5 minutes, 10 minutes, 15 minutes, for long duration, the temperature is going to increase at emitter junction as well as collector junction. Nothing but the junction temperatures are increasing. If the junction temperature increases, what are the factors affecting? I already said that previous classes. That is, reverse saturation current is going to increase because of increase of collector junction temperature increases. Here, if the temperature increases its collector junction, because of that, for every 10 degrees centigrade rise in temperature, the reverse saturation current is going to increase. That means this is going to increase. Because of this increasing, IC is going to increase. Why? Because IC proportional to IC naught. That means IC is going to increase. And after that, if the junction temperature increases at emitter junction, that means input signal, input junction, at input junction, what will happen? The voltage, the input voltage is going to decrease by 2.5 millivolts per degree centigrade. That means for every 1 degree centigrade rise in temperature, the input voltage is going to decrease. If the input voltage decreases, then what will happen to the IC? IC also going to increase. If VBE decreases, IC is going to increase. Why? Because IC is inversely proportional to the input voltage. Okay, otherwise, IC is equal to beta into IB. If VBE decreases, IB decreases. If IB decreases, IC is going to increase. Okay, in this case, the IC is increasing, and if junction temperature increases, beta increases, and IC is going to increase. This topic is already explained in my previous class. If junction temperature increases, the current is going to increase for long duration. That means the quiescent point is unstable for long duration. The quiescent point is unstable for long duration. That means in the case of fixed bias, it is unstable for long duration and stable for short duration. Then what is the stability factor in this case? What is the stability factor? Now here, the stability factor. Now here, stability factor. Now stability factor S. Sorry, first this one S. Stability factor S is given by 1 plus beta by 1 minus beta into dou I by dou AC. This is the equation for stability factor. We already solved in my previous class. S is equal to 1 plus beta by 1 minus beta into dou I by dou IC. If you want to solve this equation, you require this dou IB by dou IC. First I am going to solve this equation, dou I by dou IC. Now here, how to solve that? For that I am taking this input equation only. IB is equal from here. From here I am taking the equation. IB is equal to VCC minus VBE by RB. Okay. If you differentiate this equation with respect to IC, see here, VCC constant, differentiation of constant 0. And VBE also constant when you are determining the stability factor S. Why? Because stability factor S is defined as it is ratio of output current to the reverse saturation current whenever input voltage VBE and gain beta are the constant. That means from the definition, VBE constant. That means differentiation of constant is 0. So that's why dou I by dou AC will become 0. Now substitute this value here. So it will become 1 minus beta into 0. 1 minus 0. It will become 1 plus beta. Now stability factor S is equal to 1 plus beta in the case of fixed bias. Okay. Now what will happen to the S dash? Now S dash is defined as dou IC by dou VBE whenever IC not beta or the constant. Okay. To derive this S dash, I am taking the output current equation. IC is equal to beta into IB plus 1 plus beta into ICBO. This is from previous class only. IC is equal to beta into IB plus 1 plus beta into ICBO. Okay. Now see here. Now I am taking the equation of IB from here. Okay. Now IB is VCC minus VB by RB. Now substitute this IB in the above equation. Here you have to substitute the IB value. It will become IC is equal to beta into VCC minus VBE by RB plus 1 plus beta into ICB naught. Okay, here this is the equation after substitution. After substitution of your IB, this is your equation. Now differentiate this equation with respect to VBE. Why? Because you are solving S dash is given by dou IC by dou VBE. Now differentiate this IC with respect to VBE. See here. Now dou IC by dou VBE. Here VCC constant, it will become 0 minus VBE dou VBE by dou VBE 1. 1 into minus beta by RB. Okay. Now plus 1 into ICBO. ICBO is constant. See here. When you determine this S dash, ICO is constant. Nothing but ICBO or ICO is constant. So that's why differentiation of constant is 0. Okay. Now this beta also constant. So this is also 0. That means this total part will become 0. Why? Because reverse saturation current and beta are the constant when you are determining the S dash. So that's why this part is 0. Now this is given by S dash is given by minus beta by RB. Okay. Similarly determine S double dash. Now S double dash is given by dou IC by dou beta whenever VBE and IC naught are the constants. Okay. To determine this, I am taking again this equation. This equation I am writing here. Okay. Now d dou beta by dou beta. It will become 1. Okay. Into this part VCC minus VB by RB. 1 into this part. This. Okay. Plus this 1 into ICBO. It will become 0. Why? Because ICO is here. ICO is constant. Differentiation of constant is 0. Now 1 into ICBO 0. After that beta into ICBO here. Multiply this part. Beta into ICBO. That means dou IB by dou IB. It is 1 into ICBO. So that's why it is ICBO. Now this total equation will become IB plus ICBO. Why? Because VCC minus VBE by RB is nothing but IB. From here. From here. IB is equal to VCC minus VB by RB. Substitute here. Okay. IB plus ICBO. Okay. Now again ICBO is very, very small. So that's why I'm taking S dash as IB. Now we can write IB as IC by beta. Why? Because gain factor is defined as output current to the input current. That means beta is equal to IC by IB. From that you can write IB is equal to IC by beta. Now this is the stability factor S, S dash and S double dash in the case of fixed bias. Now see here, I already said that in the case of fixed bias, it is stable for short duration, unstable for long duration. Okay. Now what is the stability factor? The stability factor is very high. Here, why? Because S is equal to 1 plus beta only. S is equal to 1 plus beta. If beta is equal to 50, it will become 51. If beta is equal to 55, it will become 56. whatever it may be, the total stability factor is going to increase. That means very high stability factor in the case of fixed bias. So that's why the stability is low. If stability factor is high, stability is low. Okay, now what are the advantages? The advantages are simple to design this circuit. Simple to design this circuit. And second advantage is for short duration. For short duration, quiescent point is stable. For short duration, operating point or quiescent point is stable. Okay. What are the disadvantages? The stability factor is very high. That is 1 plus beta. Stability factor is very high. And second one is it is unstable for long duration. It is unstable for long duration. This is total about your fixed bias circuit.